So what we're going to do now is we're going to find inverses. And inverses are simply taking, so if we have this particular ordered pairs, 1, 5, 2, 6, and 3, 7, and you just switch them around. So the x becomes the y and the y becomes the x. So now if you look over here, b is the inverse because 1, 5 becomes 5, 1, 2, 6 becomes 6, 2, and 3, 7 becomes 7, 3. And so this obviously creates a whole new set of ordered pairs. So let's look at our current example. It says find the vertices of A, B, and C. And so we have these points because the triangle has 3 points. And we want to find the inverse of this relation. So the inverse of it, and I'll just use the notation. The inverse of A is this little apostrophe, is switching the x and the y. So the 1 becomes the y, and the -2 becomes the x, and then the 5 becomes the x, and the 2 becomes the y, and the last one is a -1, 4. Let me make that a little bit better, -1. So -1, 4. So if you look over here on our graph, where they have the apostrophes, the green graph, so I'll just do it in green. The green graph, if we plot these points, -2, 1, -2, 1 is right here. 5, 2 is right here, and then -1, 4 is right here. So all they do is plot the points. And so if we look at our original, which is the one in blue, and compare it to the one in green, this is the inverse, and that's the graph of that inverse. So what we want to do is find the inverse of a function. And to find the inverse function, we have to remember one thing. F of x is a y, so we have, this is what the function is. So to do the inverse, we're going to flip-flop the x and the y. That's what inverses are. So if I put the x where the y is, and I put the y where the x is, and now I want to solve this equation for y, that's the inverse. So if I solve for this equation, I'm going to add 5 to both sides. So x plus 5 equals 2y. Divide everything by 2. Right? Everything by 2. I get my inverse function now, y equals the x over 2 plus 5 over 2. So this is the inverse of this function. So now we want to graph both of these functions. So I'm going to graph this one in red. So I'm going to graph that by starting at -5. 1, 2, 3, 4, 5. That's our y-intercept, and I'm going to go up 2 into the right 1. And so I'm going to draw my line there. So now I'm going to do this one, the inverse, graph it. Well, 5 halves is 2.5, so 2.5 is right in the middle here. And then I'm going to go up 1 and then over 2 right there. And so I get a line such as that. And so there's the graph of the inverse. So basically we're switching the x and the y, and we are graphing that equation. So what we want to do is verify if two functions are inverses. And one way of doing that is doing our compositions. If we compose the functions, and when you do that, you get x as your answer, then they're inverses. So we're going to take, and we're going to do f composes g. So I'm going to take the g function, so I'm going to take this function, and I'm going to put it right there for the x. So that means I'm going to substitute 1/3 x minus 3 plus 9. And if we go ahead and solve this, distribute through, this is going to be x minus 9, and then we have a plus 9. And if you keep doing the math, then 9's cancel, so we get x. So FOG does give us x. So now let's do the same thing by doing GOF. That means compose f into g. So I'm going to take this function now and put it right there with the x. So that's going to be 1/3 times 3x plus 9 and the minus 3. So if I do the math and distribute that, that will be x plus 3 minus 3. And then obviously the 3's will cancel, so we get x. So the GOF and the FOG are if the compositions are equal to x, so these are inverses. All right, so let's look at our next problem and see if we have an inverse. So I'm going to do my FOG. So I'm going to take the g function, all of this, and I'm going to put it right there. So I'm I'm going to put 2 radical x, and that's going to be squared. So we're going to square that, just this part, and if you square that, the 2 becomes a 4. The radical sign disappears because radical x times radical x is x, and so that's what we get from there, and we have a 4, and so we get 16x. Well, obviously we're not getting x, so this is not going to be inverses, but let's prove it by doing the other one, GOF. So if I now take the g function, or the f function, and substitute it right there for the x, so I would have 2 radical, and I would put the 4x squared into the radical, and if we do the math of that, that's going to be 2. Simplify that, that's going to be 2x, and 2 times 2 is 4x. So obviously if you look at them, they do not equal x, so these are not inverses. So there's an example of when they do equal x, and there's an example when they don't equal x.